The other day we were talking degree measures on this circular graph. Today we're going to be measuring in radians. And this is based on the circumference area of, like, if you remember from your geometry days, it was circumference equals 2 times pi times the radius. And for our sake, we're going to say the radius is 1. So 2 times pi times 1 would just be 2 pi. So one full rotation in degrees yesterday was 360 degrees. One full rotation in radians is going to be 2 pi. Oh! So if we were to kind of, like yesterday we took the 360 and we divided it into the 4 quadrants. And 360 divided by 4 was 90 degrees. If we take 2 pi and we divide it by 4, if you look, like the fraction 2 over 4 would be 1/2, right? So each one of these would be 1 pi over 2. So at the where it was 90 degrees, we're going to say that's 1 pi over 2. At 180, that would be 2 pi over 2. And 2 pi over 2 is just pi. Down here would be 3 pi over 2. And one full rotation would be 4 pi over 2. And again, 4 pi divided by 2 simplifies to 2 pi. So this could be 0, or it could be 2 pi. And again, we're going to have those coterminal angles, so it can keep going from there as well. Let's see, do we need anything else in here? Great, so these are super common labels. Pi over 2, pi, 3 pi over 2, 2 pi. And then we're going to have to draw radian measure degrees based off of those. Now sometimes we'll have to change these. We might have to scale them to like different denominators. But remember the 180 degrees spot is always 1 pi. And then if you can kind of remember that, then it's kind of easy to scale it from there. All right, so we're going to draw an angle with the given measure in standard position. Tell which quadrant the terminal side lies in. All right, so here we go. Let's get our blank graphs. Now I want you to think, the 180 degree spot is always 1 full pi. So what I do is I look at the denominator of what they give us. These are in sixths. So if this is 1 whole, that would be 6 out of 6. So I label this 6 pi over 6. The 90 degree spot, which again, we're not using degrees right now, we're using radians, would be half of this. Half of 6 pi is 3 pi. So this would be 3 pi over 6. So if you kind of look at the pattern, we're going from 0, 3 pi over 6, 6 pi over 6. We're going up by 3 pi's over 6. So 3 pi over 6, 6 pi over 6. Down here would be 9 pi over 6. And then one full rotation would be 12 pi over 6. Once you have that, it's pretty easy to draw. So we're at 5 pi over 6. So starts at 0, and 5 pi would be between 3 pi and 6 pi. There you go, 5 pi over 6. That's it, man. Pretty similar to the degrees, but you just have to scale those, the pi over 2, pi, 3 pi over 2, and 2 pi. So this is in fourths. So what I would do is I would make this 1 whole right here, which would be 4 pi over 4. But I also noticed that this is given in negative radians. So I'm going to make that negative 4 pi over 4. What? Now remember, negative measures start at 0 and they dip down first. So if this is negative 4, down here would be half of that. Half of negative 4 would be negative 2. So we'll have negative 2 pi over 4. So down here is negative 2. Negative 4. Keep the pattern going. Up here would be negative 6 pi over 4. Negative 2, negative 4, negative 6. One full rotation would be negative 8 pi over 4. Again, once you got the labels, it's not too bad. We're graphing negative 1 pi over 4. So it starts at 0, and it's dipping down. We have to get to negative 1 pi over 4. Here's negative 2 pi over 4, so it would be half of that. Negative pi over 4. All right, and then this one is in twelfths, and it's positive. Woo! Luckily. So pi is over here. That would be 12 pi over 12. Right, that would simplify to 1 pi. But that's going to make it easy to scale. Up here would be half of that, so 6 pi over 12. So we're going by sixes. We have 6 pi, 12 pi over 12. Down here would be 18 pi over 12. Over here would be 24 pi over 12. Now, I'm just noticing that I forgot to say which quadrant they end in. We'll get that all at the end. This one we want 23 pi over 12. It always starts at 0. Now 23, pretty darn close to 24, so it's going to have to go pretty much a whole rotation. That would be our 23 pi over 12. Now let's talk quadrants. Here's how I remember my quadrants. It goes like the letter C. So, or if you're thinking of the coordinate plane, that starts with C. So up here is quadrant 1, here's quadrant 2, down here is quadrant 3, and down here is quadrant 4. So this one has, it terminates, it ends in quadrant 2. Q2. This one ends in that bottom right quadrant, that's quadrant 4. And then this one over here also ends in quadrant 4. Cool. Not too bad. Coterminal angles. So again, yesterday when we were doing degrees, we added and subtracted full rotations. And a full rotation in degrees is 360 degrees. But now we're using radians. In one full rotation on radians, that's 2 pi. So we're going to add and subtract 2 pi to find coterminal angles. All right, we'll draw them. Maybe. Oh boy. So if we were to draw 5 pi over 6, we're in sixths, so here would be 6 pi over 6, which makes up here 3 pi over 6, 3, 6, down here is 9, and then 12 if it was a full rotation. Also, that could be 0. So if we're drawing 5 pi over 6, that would start at 0, and it would go to there. 5 pi over 6, yay! Then it has us draw negative 7 pi over 6, so it's negative radians. So that would make this negative 6 pi over 6, which means the negative 3 pi over 6 would be down here. So we have negative 3, negative 6. Up here would be negative 9. And then here would be the negative 12. So if we're doing negative 7, that's going to go just beyond negative 6. And it has that same terminal side. Those are coterminal angles. They end in the same place. They are 2 pi away from each other. If you did negative 7 pi over 6 plus 2 pi, it's going to give you 5 pi over 6, which is what we're going to practice now. We're going to practice adding and subtracting 2 pi's. Find the measure of a positive angle and a negative angle that are coterminal with each given angle. Now here's what I like to do when I'm doing these myself. I say 2 pi over 1, but we're going to be adding and subtracting fractions, and you have to have that common denominator. So if we're dealing with thirds on this first one, you just multiply them by 3. So one full rotation here would be 6 pi over 3. Again, that simplifies to 2 pi. So we're going to add and subtract that. So if we do 5 pi over 3 plus 6 pi over 3, they're both thirds, so we just have to do 5 plus 6. It'd be 11 pi over 3. There's a positive coterminal angle. Now let's subtract a rotation. 5 pi over 3 minus 6 pi over 3. That would give you negative 1 pi over 3. You don't write negative 1 pi. You're cooler than that. You just write negative pi over 3. Cool. So we're adding rotations. Now if you look at this one, it's given in fourths. So if I'm scaling 2 pi over 1 to fourths, just multiply by 4. That'd be 8 pi over 4. So we're going to add and subtract an 8 pi over 4. So negative 7 pi over 4 plus 8 pi over 4. Negative 7 pi plus 8 pi is 1 pi. So this would just be 1 pi over 4. Yes! We're also going to subtract a rotation, negative 7 pi over 4 minus 8 pi over 4. Negative 7 minus 8 is negative 15. And then you got your pi over 4. Yay, fun, all right. And this one's given in halves. So if we're scaling 2 pi over 1 into halves, that would be 4 pi over 2. So we're going to add and subtract a 4 pi over 2. So 13 pi over 2 plus 4 pi over 2 would be 17 pi over 2. That is one positive coterminal angle. Remember, there are infinite. You could keep adding 2 pi's to everything. Now we're going to subtract the 4 pi over 2. (13 minus 4 is 9, so we're still positive. So we're going to have to subtract another rotation, which is another 4 pi over 2. And that will give us 5 pi over 2. Holy cow, we're still positive. We're just so positive today. So let's subtract another rotation. 5 pi over 2 minus 4 pi over 2. Oh my gosh. That's still 1 pi over 2, or pi over 2. We're still positive. These are all positive coterminal angles. But if we subtract one more rotation, then we'll be negative. 1 pi minus 4 pi is negative 3 pi over 2. So there's our first negative coterminal angles. But you can keep subtracting 4. Negative 7 pi over 2, negative 11 pi over 2, negative 15 pi over 2. It's not too bad. I believe we're going reference angles now. So remember yesterday with the degrees, and you don't need to write this, but I'm just refreshing you. If we're looking at how a boop, let me just sketch up here. So in degrees it was, our labels were 90, 180, 270, and 360, or 0. If you had a terminal angle end in quadrant 1, the reference angle was just equal to theta. It was just whatever the angle was. In quadrant 2, yesterday we had to do 180 minus our angle, our theta. Quadrant 3, we did our angle minus 180. And then in quadrant 4, we ended up doing 360 minus our angle. Very similar now, except we're going to use radians. So in radians, keep it rad. Remember our labels that we use all the time. Well, let me label the quadrants first. Quadrant 1, yes. Oh, over here is quadrant 2. Down here is quadrant 3. And here we have quadrant 4. So our labels for radians, this was 1 whole pi, right? The 180 degrees was pi. Up top at the 90 was the pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, and then 4 pi over 2 is just 2 pi. And again, that could also be 0. So similar to in degrees, if it ends in quadrant 1, it's just the degree of our angle here. So reference angle is just theta. Now in quadrant 2, in degrees, we did 180 minus theta, but we're not using 180 degrees, we're using radians, so this is pi now. So we're going to do pi minus theta. Down here before, in degrees, we did our angle minus 180. But instead of 180 degrees, we're using pi. So we're going to do our angle minus pi. And then here, our reference angle in degrees was 360, one full rotation minus our angle. So we're going to do one full rotation, 2 pi, minus our angle. And once you see it set up, I think once they're graphed, they're a lot easier to find. So that's what we're going to do now. Find the measure of the reference angle for each given angle. All right, we're going to have to draw some graphs here. You know what's wild? I'm feeling fresh right now. I say let's label all of these right now. Now remember, 180 degrees is pi. It's one whole. So let's look at the fractions they give us here to see what we're dealing with. This first fraction is giving us pi over 6. So we're dealing with sixths. So this would be 6 pi over 6, because that's one whole. Cool. This one's dealing in thirds. So this would be 3 pi over 3. This one's dealing in fourths. So this would be 4 pi over 4. Those all simplify to 1 pi. And once you have that, you can scale the rest of it pretty easy. So up top, that top angle is going to be half of this. So 3 pi over 6. And we're going by threes. 3 pi, 6 pi, 9 pi, 12 pi. This one's a little tougher because one whole is 3 pi over 3. If you did half of 3, that's 1.5. And that's fine. It doesn't matter. You don't need to change it, because we're just kind of making sure that we end up in the correct quadrant. So we're going by 1.5. So 1.5, 3. Down here would be 4.5. And a full rotation would be 6. Cool. Here we're going by fourths, right? So half of that would be 2. 2 pi over 4. 2 pi, 4 pi, 6 pi over 4, 8 pi over 4. Find the measure of the reference angle for each given angle. So here we're drawing 1 pi over 6. It starts at 0. 1 pi is a third of the way to 3 pi over 6, right? So it's just going to pi over 6. Now remember, if it ends in quadrant 1, that angle is the reference angle. So we'll say reference angle is pi over 6. Woohoo! All right, on B, we're going to 7 pi over 3. That's more than one full rotation. So we're going to have to go past 6 pi. How much further? We're going to 7 pi over 3, and we've gone to 6 pi. So we need to go one more pi. This would be our 7 pi over 3. Now, it ended in that top right quadrant, which this whole time I've been like, then it's just your reference angle. But we wouldn't say our reference angle is 7 pi over 6 because that's not an acute angle. This is the acute angle. So we need to think in our brain, how much further did we go past that 6 pi over 3? We went to 7 pi over 3. So we just went one more pi over 3, right? 7 pi minus 6 pi is 1 pi. So our reference angle on this one would again be pi over 6. Kind of boring. And then if you look at this one, we're going to 9 pi over 4. Again, that's going to go beyond one full rotation. So one full rotation is 8 pi over 4. We need to go to 9 pi over 4. So one more. Now 2 pi is up here, so it would be halfway to that. 9 pi over 4. Again, if you just wanted the coterminal angle, you could subtract the 2 pi off of that, which would give you 1 pi over 4 for the reference angle. It went 1 pi over 4 beyond a full rotation. Cool. Here we go, the last thing, converting between degrees and radians. All right, now you'll see both of them have the same conversion factor. They're both pi radians and 180 degrees. Now you can memorize what they have up here, but I don't think that's necessary. Here's what we're going to do. We're going to take what they give us, 60 degrees, and I'm going to put it over 1. 60 degrees over 1. Now we're trying to cancel out the degrees. Think about fractions. When you cancel stuff out, it's got to show up in one numerator and one denominator. So if I'm trying to get rid of degrees, and I have it in the numerator right now, I'm going to put it in the denominator. So the 180 degrees is going to go down here. It's always 180 degrees, and it's always pi radians. So the other side will just be the pi rads. We'll simplify before we multiply. It's easier that way. You could multiply and then simplify, but let's just do it now. 60 goes into 180 how many times? 3 times. So we're going to cancel out this 60 degrees, we'll make it 1. We're going to cancel out this 180 degrees, we're going to make it 3. You can't simplify anything else. So we have 1 pi up top, and then 1 times 3 is 3. So we have pi over 3 radians. That's pretty easy, right? You can simplify fractions. The only tricky part is remembering like what goes in which part of the fraction. So if we were to try this, pi over 4. You could put pi over 4 over 1, but that's kind of strange. Just put the 4 as the denominator. So we're going to have pi over 4 radians. Again, we're trying to cancel out the radians now. It's in the numerator, so we'll put it in the denominator. Pi radians. The other end of the fraction is always 180 degrees. So, pi cancels pi. Radians cancel radians. So basically, we just have to do 180 degrees divided by 4. If you want, you're like, hey, they're both even. I could cut them in half. Half of 4 is 2. Half of 180 degrees is 90 degrees. And then it might be easier to do 90 degrees divided by 2. I don't know. So it just comes out to 45 degrees. That's it. Pi radians and 180 degrees is the conversion factor. Just make sure you put them in the correct spot of the fraction.